All right. Algebra 1B, Unit 1.3 notes. We are going to be solving radical equations, equations that involve a radical. Specifically, we're going to talk about square roots. Our mathematician for the day is Peter Landon, a relatively recent mathematician. He only passed in like 2010. He was a gay rights activist and a founder of some of our modern computing languages. He's the one who figured out that there was a tie between some of the math and some of the computer languages that they were working on at the time. So he kind of made a lot of that stuff possible. Just an icon upon himself. Look him up sometime. So for the notes, we have radical expressions versus radical equations. A lot of people get this kind of stuff messed up. When I say radical, again, keep in mind I'm talking specifically for us about square roots. And really what we're boiling it down to what an expression is versus what an equation is. So a radical expression is something that has no equal sign. No equal sign whatsoever. An expression is just a statement. Like me saying the wall is orange, the table is white. It doesn't require a response from you. A statement is just something that exists upon itself. So no equal sign, that's something like square root of 25x squared. That's something that we would have looked at in our 1.2 notes. That is something that we simplify. So if I was to make that into regular language again, I might say something like, my shirt is a bit of a mixture of red and blue. And you would just say, so purple. You're simplifying my statement. You're taking what I have and making it more compact, or maybe a better way of saying it. What differs for an equation, so radical equation, is that it has an equal sign somewhere. So in this lesson, in this page of notes, we're going to look at stuff like square root of x equals something like 15. When I give an equation, it's more of a question. So if I was to say, what color of chair are you sitting in right now? You would then be prompted to answer me. You wouldn't just sit there and stare at me because that would be a really weird interaction. If I said, hey, what color is your chair? And you just went like, I'd be, we rest of people in the room would be getting weirded out. Square root of x equals 15 is asking the question, when does the square root of x equal the number 15? So that requires a response. We are not going to simplify. We are going to solve so that we can actually answer the question. When does square root of x equals 15? Well, let's find out. So that's what this lesson is going to be about. And it always bothers me when people use the wrong language, not because they're wrong, but it makes it harder to communicate. When a student comes up to me and says, hey, did I solve this correctly? Well, if you don't need to solve the problem, don't worry about looking for a solution. In this page of notes, we're going to find solutions, whereas in the previous page of notes, we were just simplifying what was there. So diatribe aside, moving into some more vocab here. An extraneous solution is a really big word, and it's one that I like to go home and scare your parents with. We learned about extraneous solutions today. I want you to focus on the word at the beginning, extra. It's really just an extra solution that you don't need. An extraneous solution is a false solution found. And what do we do with false solutions? We just delete them. Oops, I accidentally found this. Let me fix that. Let me get rid of it. We'll see some examples of that occur later on. The best way to check for it and to tell that you actually found a false solution is to backsub, and that is going to be a requirement in this lesson. You must backsub and check your answers. In the process of solving a problem, let's say we had square root of x equals -2, you will find the solution. So I'm just going to put dot, 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 because we're not ready for that part yet. You're going to find the answer of x equals 4. And what you're supposed to do at that point is, I like to write the words back sub. We are plugging our answer back into the equation and seeing if it makes any kind of sense. So square root of x is now going to be square root of 4 equals -2. Now, as a reminder for when we're typing square roots in our calculator, you can press the second button and the x squared button to get a square root. That's the process that you're going to type. That's the things that you would need. So for square root of 4, take a moment, type that in. You're going to press second, square, and then 4. When you type that in, you get 2. So then our answer is 2 equals -2. That ain't right. What the heck? When that happens, you get rid of your answer and you say no solution. You have to try. You have to find your solution as best you can. But we are going to back sub and we're going to test our answer. Now, to get in the actual process of how we would get that answer to back sub, we're going to follow these steps. Step 1, you are going to isolate. Of course, I spelled that like a madman. Isolate the square root. And if you think about the word isolate, it means to get alone. So you're going to try and get the square root alone. All the stuff that's outside of it, you have to cancel. Second step, you are going to square both sides of the equation. And by square both sides, I mean do a parentheses with a literal square. You are then going to solve for x. And then finally, you are going to back substitute. Back substitute to check for any extraneous solutions. And that was the step that we just did right up here, where we back subbed. A good thing to keep in mind, square root and square cancel. If you ever have both, we call these inverse. Works the same way if you have add and subtract, multiply and divide. Square root and a square, they cancel one another. So on the next page, next page, we will have some examples to look at. It says solve each of the following. We have 6 square root of x plus 6 equals 36. So step 1, we are going to isolate the square. So to do that, I need to find everything outside this square root, and I need to cancel it. So first, I'm going to subtract the 6 from both sides. So we've got 6 square root of x equals 30. After that, we need to find a way to get rid of the 6 that is in front of the square root. Whenever you're working in math and there's a missing operation, it's a times. So 6 times square root of x equals 30. To cancel a times, we are going to divide. So then square root of x equals 30 divided by 6 is 5. Now the square root is alone. So we are ready to move on to step 2, square both sides of the equation. To cancel the square root around everything, we are going to put a parentheses and do a power of 2. Now, as we mentioned earlier, a square root and a square cancel with each other. So that square root and that square are gone. You are left with only the x. And if you do 5 squared in your calculator, parentheses 5, parentheses power of 2, you will get 25. Now, ideally, we would be done because step 3, solve for x, we don't need to worry about doing. We've already got x solved for, it's already done. But there's an extra step at the end where we need to back substitute. And yes, this is for points. You have to do this. Our back sub, you are going to rewrite this equation, but instead of writing the x, you're going to write 25 because now we know what x is. 6 square root of 25 plus 6 equals 36. And from here, we're just going to try and simplify. If you try and solve this, you might end up creating the same error that created this, if it is an error. So I always recommend when it comes to this stuff, just simplify. Just type things in the calculator. Square root of 25, that's an easy enough one for us to do. So we have 6 times, that would be 5 plus 6 equals 36. And from here, we have 6 times 5 plus 6. You could type that all in the calculator at once. That results in a 36. So 36 equals 36, which is true. So then, hey, we can circle our answer. Next problem, we are again starting by isolating the square. So this 5 out in front's got to go. We're going to divide it away. Square root 2x plus 1 equals, this would be -3. To cancel the square root, now that there's nothing outside of it, we are going to square both sides. So we have 2x plus 1 equals -3 squared. If you're very careful about how you type that in your calculator, make sure you do parentheses. You will get a +9. Step 3, solve for x. To do that, we are going to subtract 1 from both sides. So then the 1's cancel. 2x equals 8. And then lastly, divide away the 2. So that x equals 4. Our last step is going to be to back sub. So on the side, we are going to rewrite this equation. And instead of the x, we are now going to write a 4. So 5 square root 2, and then 4 plus 1 equals -15. And we're going to start just plugging some of these things in, see what we can get. We have 5 square root, 2 times 4 is 8, plus 1 is 9. So 5 square root of 9 is -15. Square root of 9 is 3, so 5 times 3 equals -15. But 5 times 3 is not equal to -15. So since that is not true, we mark out our answer and we say that there is no solution. We had to do everything we could in order to find a solution, but the one that we found was false. We marked it out, said there's no solution, we move on with our lives. The next one, 3 square root x plus 2 minus 5 equals 4. Again, we're going to cancel the stuff on the outside. So plus 5 to both sides. 3 square root x plus 2 equals, this would be 9. To cancel the 3 in front, we are going to divide by 3. Square root x plus 2 equals 3. Now that we're at the stage where the square root's alone, we are going to square both sides. So that x plus 2 equals, this would be 9. And finally, if we subtract 2 from both sides, we get x equals 7. And so now that we have an answer, we're going to back sub it and try to see if we can get it to work. Keep in mind, if at any point you need to pause, rewind, rewatch, feel free. So our back sub, 3 square root, instead of x, I'm going to write 7. And we're going to simplify. 7 plus 2 is 9. So 3 square root 9 minus 5 equals 4. Square root of 9 is a 3. So we really have 3 times 3 minus 5 equals 4. And then if you type that in, 3 times 3 minus a 5, yeah, that's 4. So we get to circle our answer. I would definitely challenge you to pause, try that last one for yourself. Negative 5 square root 2x minus 3 equals negative 25. We will start by dividing both sides by negative 5. So that square root 2x minus 3 equals 5. To cancel the square root, we are going to do a parentheses with a square, and we will repeat that for the other side as well. So then 2x minus 3 equals 5 squared, which is 25. To cancel the minus 3, we will add 3 to both sides. So then 2x equals 28. And then lastly, you are going to divide by 2, which leaves you with x equals 14. When we back sub, we have negative 5 square root 2 times x, which is 14, minus 3 equals negative 25. Simplifying this, 2 times 14 minus 3 in your calculator would get you a 25. So negative 5 if you square root the 25, that results in a 5. So negative 5 times 5 equals negative 25. And that's true. So we can circle our answer. The last problems, we've got 3x minus 1 equals 2x plus 4. When we're working with this one, we've got a square root on both sides. So I would recommend you should put a parentheses with a square and a parentheses with a square. If you square both sides, that's going to be able to cancel both of those square roots. So we have 3x minus 1 equals 2x plus 4. And from here, it's just a problem you would have faced in Algebra 1A. We need to get like terms together. I've got a 2x and a 3x, so I'm going to minus 2x from both sides. Cancel that. 3x minus 2x is a 1x. Minus 1 equals 4. Our next like terms are the negative 1 and the 4. So if I add 1 to both sides, I get 1x, which is just x, equals 5. Now, what makes this one different from before is now I've got two different x's I have to plug into. I got my x is 5, so I'm going to plug those in, see what I can get. Back sub square root 3x minus 1. Oop, I don't know why I did that. I'm supposed to change the x. X is now a 5 minus 1 equals square root 2 times x, which is again 5 plus 4. 3 times 5 is 15, minus the 1 is 14, so square root of 14 equals 2 times 5 is 10, plus 4 is again 14. So square root of 14. So square root of 14 equals square root of 14. We are good to go. Circle your answer. The last problem here, same idea. So I'd recommend pausing and trying it yourself. Parentheses with a square would cancel the square root, so negative 3x plus 4 equals 2x plus 14. We can minus 4 from both sides to cancel the 4, so negative 3x equals 2x plus 10. We can minus 2x from both sides. So then negative 3 minus 2 is negative 5x equals 10. And then finally, you need to get the x alone. So divide by negative 5. We get x equals, this would be negative 2. Well, now that we've got a negative 2 as our answer, let's try to plug it in with a back sub and see if it works out. Square root negative 3 times x, which is negative 2, plus 4 equals square root 2 times x, which is negative 2, plus 14. So if we simplify this, negative 3 times negative 2 is 6, plus 4 is a 10. So square root 10 equals 2 times negative 2 is negative 4, plus 14 is also 10. So then those equal, and we get to circle our answer. All right. After this being our last lesson of Unit 1, you guys will then be working on the review after this assignment, and then after that will be the test. So tomorrow is just review day. I'm going to get blank sheet. You can practice all those problems. They're going to be very similar to what's on the test, and then be ready for the test. Keep in mind, on every test you take from my class, you can use one piece of printer paper, and you can write whatever you want. One page, one side, you can use that on the test. So I call that a toolbox. Think of it kind of like a cheat sheet. Formulas, examples, stuff like this would be good to write for yourself. Take your notes, spread them in front of you, pick out what things will be helpful, write it on your toolbox, use that on the test. Remember, one page, one side, write whatever you want, use that on the test. You can use a calculator, the toolbox, factor sheet, that's it. No notes, no friend, you got to use those things. All right, good luck, everybody.